Hello and welcome to the lecture Hierarchical Planning based on the example of MRP. So what we're going to do here is that I'm going a brief introduction about hierarchical planning itself, and then we immediately jump into the material requirement planning. MRP is widely used in industry, and the most famous ERP system is SAP, which is a German software company. On this slide, you can see the hierarchical planning supply chain matrix from Rode or Stadler. The nice thing what they have published here is, on the one hand, you can see the process thinking from procurement, production, distribution, and sales. And on the other hand, you can see the hierarchical levels from long-term, medium-term, and short-term. So in general, long-term decisions are decisions more than 5 years. Decisions which can be done here are, for example, is there a new production facility needed? Yes. Are we going to build a new one? Where are we going to build this production facility? So this is a decision, for example, based for the production process. Of course, for procurement, long-term relationship to suppliers can be generated here. Contracts, long-term contracts. Also, the distribution channels can be negotiated in long-term decisions, and also the sales, so that you have contracts with your customers. So, for example, BMW has long-term contracts with customers to sell their cars. Those decisions are set up in the strategic planning. In the medium-term planning, you can see one of the important things is the master planning. This phase, you are not thinking in individual items and not on a specific time. So you don't want to know which BMW has to be produced tomorrow, but you're interested on a product group which should be produced, for example, in this month or in the next month. So the master planning does aggregation based on items to product groups, and on the other hand, there is aggregation in terms of times, so that the planning task in general is getting not that complex. And on the sales side, you have the demand planning, which is more or less responsible for predicting the future demand. So all the predictions, the models are used in the demand planning. And once you have done the master planning and the demand planning, you can go within the medium-term sessions of calculating the when it's necessary to order raw material or components which are used in your production or in your assembly plants. So this is done in the procurement section. On the other side, in the production planning, the production orders are calculated so that you know when you have to start your production, what you are going to produce, and the quantity what you're going to produce. And for the distribution, you need orders so that you know what you're going to distribute. For example, if you are a DHL driver, you need to know what to put into your vehicle so that you can deliver the items to the point of destination. And then it depends in industry if there is, for example, a scheduling, if the setup of the equipment is very expensive, then there is also a scheduling so that the sequence of all available production orders are determined, so that the worker is not allowed to do the scheduling by him or herself. Instead, an algorithm is optimizing the sequence of the production schedules, or determining the production schedule. The same goes with the transport planning. So once the DHL driver has loaded the truck, then his beautiful device tells him the next location and which items he or she has to deliver there. So he is not doing the tour planning by him or herself. So instead, an algorithm is telling the optimal route to unload his truck again. And here we have a very interesting function, the demand and fulfillment and available to promise function. This is needed if you are customer orientated, meaning you are calling a company and you request a certain item, and then the company is able to tell you, yes sir or ma'am, we have that item on stock, you can immediately get your item. Or if it's not on stock, then the company can tell you, yes, it's possible, but you have to wait for example, 2 weeks. Then we have your requested product on stock and you can purchase it. If companies don't have an ATP function installed, it's just guessing, yeah, and then the customer gets not satisfied because then the promising due dates for his order are violated and his products are not arriving. He is getting annoyed, and then perhaps the customer is canceling this order, and we will have lost sales in this circumstance. So this is the supply chain planning matrix. The huge advantage is you have process thinking and you have an hierarchical planning approach included. And for each module, different concepts are available. For instance, here mixed integer programs are used. So we are going to discuss in this course basic models of linear programming. And then we are also having a look more detail on a production planning method, which is also used for purchasing and material requirements planning, which is called the MRP. So at least we will discuss 2 methods applied in industry to get you an introduction how methods are working. So what we can see here is a second approach from Hopp, Sperman. The book is called Factor Physics, and here we can see the manufacturing resource planning, the MRPII approach. Here you can see again the same 3 layers: long-term planning to medium-term planning and short-term planning. In the long-term planning, we have the demand planning, which results in the demand forecast. Most likely, the long-term planning is again an aggregated production plan, meanings in terms of items and in time. Based on this demand forecast, you can start with an production planning so that you know what to produce in which month. And based on this plan, you are able to define capacities in long-term view. Meaning, I request facility A in China for 10% of the utilization. I request the facility here in the Netherlands for 55% of the utilization. So that means you're able to plan your capacities, and capacities can be machines, equipment, and of course you can also plan your manpower. For example, if you ramp up a new plant somewhere in the world, you need to know how many employees, how many skilled employees, how many trained employees, technicians are needed, how many unskilled people are needed, and this has to be done in a long-term view. Based on that, the aggregate production plan is the outcome. Then the master planning takes place, which again takes in consideration the production plan, which is forecast driven, and it takes also the actual amount of customer orders which have been already in our books into consideration. And then the disaggregation happens in the master planning, and the outcome is the MPS, the master production schedule. So this MPS is a disaggregated plan right now, depending on forecast data and depending on actual customer orders which are in our order books. Here a rough cut planning takes place, which has more which is already disaggregated, so that you can make an accurate capacity planning. This is especially needed for employees, hiring and firing employees, and also for specialized equipment, because it's not that easy to scale up production speed and or the production outcome of your equipment and facilities. And then the MRP approach translates the MPS data into production plans. And the production plan has the characteristics, or the outcome of the MRP has the characteristics that you need to know what you are going to produce, when do we have to start with our production, when has the production to be ended, and how much of those items are we going to produce. And then finally we have a job pool which can be released into production. And now it depends on the item or about the industry, if a scheduling is necessary, or if manpower is enough to sort out which of those orders are going to produce next. And finally, you can also do the capacity planning based on the job pool. Yeah, but the problem is here you only can take into consideration the orders which have been put already in the job pool. Yeah, and you don't know which capacity will arrive in the future. Therefore, the resource planning and the rough cut planning are quite important. Here you can, for example, just adjust shifts so that you allow or identify people who are working in the first, second, or third shift. And of course, you can plan overtime if something goes wrong. For example, a tool breaks down and you lost capacity. Then in this capacity planning part, you can plan that you need, for example, overtime at the weekend, and then your employees are working at the weekend. And this is so-called the shop floor, which is the actual production. So here we are down at the machines, at the employees. They are producing what you have or what we have planned here so far. As input for the MRP is the bill of material. We see that in our example later on. And of course, you need the actual inventory status and the planned orders which you have planned in previous MRP runs. You need to know the routing data, which machines are necessary that you can produce your final items.